Welcome back to our YouTube channel. So today we have a topic to discuss. This topic seems to be simple, but there are some techniques you need to know about this particular topic. And we are going to discuss that in today's class. So the topic today is standard form. Now, do you know that the Earth is about 4,543,000,000 years old? Now, if you are to write down a number, you have 4,543,000,000 years old. You can see how large the number is. For instance, in a common language, some people will say it is 4B or 4M. Now, what does 4M stand for? Or you must have been hearing the slangs saying 3K. Can I have 3K there? That 3K is just what a form of what of abbreviating a very large number. You can say 5K. 5K simply means what? 5,000. That's in a layman explanation. That's in a layman explanation, not mathematical term. So if you have this and somebody tells you that can I have 5K, it simply means what? 5,000. So in mathematics, there is also a way in which we express a very large number, and this way or this manner is what we call standard form, or we call it uh, scientific notation. So that is what we're going to discuss today. What if you have a very large number like this, 4,543,000,000? Now, to write this same number in a simpler manner, we need to apply our standard form knowledge. Now, to rewrite this, you can just say 4.543 billion. 4.543 billion. Now, the standard form expression is what we have here. So before we proceed, let's discuss what standard form is. So standard form is a way of writing very small or large numbers in an easier manner by comparing the power of 10. We compare the power of what? Of 10. Now to express that same number in standard form, we have this A stand for a number. A number, this A stand for what? A number times 10, then exponential what? The n that we have here. This n simply means what? An integer. This n is an integer and it could be positive or negative in mathematics. So we express this. So a is a number between 1 and 10. The a is a number between 1 and 10. That is, a is less than or equal to 1 or less than 10. Let's talk about the standard form notation. Standard form notation. Let's recall our previous knowledge on place value. Let's recall our previous knowledge on what on place value. We recall that when we have 111 point, this point is a decimal point. 0.111 again. Now this 111, they are regarded as what? As your whole number. These three numbers that you have here, they are regarded as what? Whole number. And if we are to pronounce this in what? In words, you can say 100 and what? And 11. This is 100 and what? And 11. Where this one here is what? Is units. This next one here is 10. And this next one here is what? Is 100. Now, note that there is no unit in decimal number. There is no unit in what? In decimal number. That is why we are having what? 1 over 10, which could also be written as what? 0.1 in decimal number. We also have 1 over what? Over 100. That is, it's telling you that the place value of this one here is what? 100. The place value of this one here is what? Tenth. Or you call it 1/10. This place value here for this number is 100. And the place value for this one here is what? 1000. We recall that anything raised to power 0 is always equal to what? 1, which is units. That is 1 times 10 raised to power 0 is what? 1 times 1, which will give us what? This one here, which is units. And we also have 10. If you're having 10, you always have what? A power of what? Of 1. Your 10, we always have what? Power of what? Of 1. And when you are having 100, your 10 will always have a what? A power of what? Of 2. And when you're having 1000, power of 3, tens of 1000, power of what? Of 4. Now, when we get to this decimal what? The next number which is expressed in fraction. This number that is expressed in fraction, the next number is what? Their decimal number. So we have 1 over what? Over 10. That is 1/10. So we have 1 times 10 raised to power minus 1. As the case may be, we proceed when we have 1 over 100. That will be what? 1 times 10 raised to power minus 2. In fact, in this case, you can even rewrite this number by saying raised to power 1. This one is times 10 raised to power what? Power 2. You can write this one as 1 over 10 raised to power 2, which also means this. The next one is this 1 over 1000, and it can be written as 1 times 10 raised to power minus 3. Why are you having your minus? Because you are dividing the number by the place value of that same number that you have here. Now, the next one is 1 over 10,000. That is, you have what? Your 1 times 10 raised to power minus 4. This number here can be written as what? 1 over 10 raised to power 4. And whenever you want to express it in standard form like this over, this bar is going to change towards to minus 4. So let's discuss the difference between ordinary number and standard form number. The difference between ordinary number and standard form number. Now, take a look at this. These are ordinary numbers and these are standard form numbers. Now, when we have 29, now to express this in standard form, we recall that the expression in standard form where we talk about the word the A representing what the number to be less than or equal to 1 and less than what than 10. So that is why we are having this 2.9. It won't be 29 anymore because the number that we want to express in standard form must be less than or equal to 1 or less than 10. Now, the next one is this. Can you see? If we are moving the what? The number, we are dividing by what? By 10. If we want to convert it back to this what? Whole number, we need to multiply this 2.9 by what? By 10. Now, the second expression is this. What is the place value of this 0 here? This is unit, tens, and hundred. So this is 350. Now, to express this in standard form, your first digit should be less than or equal to 1 and less than 10. So we need to what? Put our point after this word, this 3, which is the first number, you put your point, then you have the word, your other number, times 10, and the word, and the power, which is what? Your integer. And this is the positive word, integer. Now, to convert this number, 3.5, back to this word, ordinary number that we have here, we need to multiply by what? By 100, which is 10 raised to power 2, which is 10 raised to power 2. Now, the next one is this. Can you see the way we move it? This is 1, 2, 1, 2. That's why you're having times 10 raised to power what? That's why you're having times 10 raised to power 2. Now, let's check the next one. We're having times 10 raised to power 3, right? How did we get a 3? Let's see. 1, 2, 3. You put your point there. The next one. Now, this number now, these are decimal number, all the one we just discussed earlier, they are what? They are whole number. Now, how are you going to go about the decimal number? How are you going to go about the decimal number? All you just need to do is to say 3 over what? Over 10. So 3 over 10 is going to give you what? 0.3. So 3 over 10 is going to give you what? 0.3. Now, to express this in standard form, all you need to do is to what? To say 3 times 10 raised to power minus 1. 3 times 10 raised to power minus 1 because we are dividing. How do we get the minus 1? You can just take over your simple method by moving your decimal point to the right hand side, and that will be what? Negative. All this one will be positive, positive, and that will be what? Negative. Remove the arrow one, that's minus 1. Now the next one, if we are going to what? Express 0.09 in standard form, our 9 is what? Is less than 10. It's less than 10. So we move it 1, 2. Your point will be what? Will be here. That's why you have what? Minus 2 here. The next one is what? 0.0071. So let's put our point after this 7, which was the number less than 1 than 10. So we count 1, 2, 3. You put your point in between the 7 and 1. And that would be what? 7.1 times 10 raised to power what? Minus 3. So in other words, you're going to be having 7.1 divided by what? By 1000, and you can express that as this. To get this number back, we multiply it. When we multiply this by 1000, we get our number back. Any zero between a digit or a figure is a significant word number. Please take note of this. Let's move to the next aspect. This question says expressing whole numbers in standard form. Expressing what whole numbers in standard form. Now let's express these numbers in standard form. The first thing we need to do, that is our 4500. The step one. Our step one is to identify the non-zero digit number. Non-zero digit number must be less than or equal to 1 or less than what? Less than 10, which is what? 4. Step 2 is to what? Is to write the power of 10 as what? As an exponential. So we have 10 raised by what? 10 raised by 3. Now, step 3. So our step 3 is to write our number in standard form. Our step 3 is to write our number in standard form. So I'm going to go back and we say 4.5 times 10 raised by what? 10 raised by 3. That is our what? Our answer. So we're going to be applying these steps and the remaining question. So let's go. The next one is what? 4800000. In standard form is going to be 4.8. Now 4.8, let's go. 1, 2, 3, 4, 5. 5 is going to be what? The power of what? Of 10. So we have times 10 raised by what? 5. That's our answer. The next one is what? 5420000. So to express this, this will be 5.42 times 10 raised to power, let's see, 1, 2, 3, 4, 5, 6. Times 10 raised to power what? 6. That's plus, because we are moving to the what? To the left. This is plus. Now, the next one, which is D, that is what? The D is 4480000. Now, let's express it in standard form. That will be 4.8 times 10 raised to power 1, 2, 3, 4, 5, 6. Times 10 raised to power what? Times 10 raised to power 6. That is million. That is 1 million. So, to get this whole number back, you need to multiply this word 4.8 by what? By 1. That is what it means. The next question is 9084000. Now don't forget I told you that when a zero is in between a number, it is what? Significant. But if it is after the number, it's what? It's not significant. So let's express this number in standard form. Let's consider the first word, the first digit, which must be what? Less than or equal to 1 and less than what? 10. So 9.084 times 10 raised to power what? 1, 2, 3, 4, 5, 6 times 10 raised to power 6. So these are the way to express our numbers in standard form. So let's move to the next aspect. We want to express the decimal number in standard form. So now let's convert decimal number to standard form. Now, before we convert this number to standard form, I told you that the first step you need to do, let's take it again. The step 1, that's 0.00081. Now to solve the step 1, identify the non-zero digits. So we have this 8.1. We have identified the non-zero digits. Our step 2, to write the power of 10 as an exponent. That is, we have 1 over what? 1 over 1, 2, 3, 4. 1 over 10,000. Tens of what? Of 1,000. This is 10, 100,000. 10 of 1,000. That's what we have our decimal point here. And this can also be expressed as 10 raised to power 4. 1 over 10 raised to power 4. Now, step 3 is to write our answer in standard form. Our step 3 is to write our answer in what? In standard form. So this will be 8.1 times 10 raised to power minus 4. That is 10 raised to power minus 4. So the step 1 says we should identify the non-zero digits. So that will be 7.18 times 10 raised to power times 10 raised to power what? Just take the what? 3, 1, 2, 3. Times 10 raised to power minus 3. That is the what your answer in standard form. In other words, that is 1 over what? 1000. So C question is 0.68. Now, 0.68 will be written as 6.8 times 10 raised to power times 10 raised to power minus 1. Because we just move our decimal point to 1. So that is what? 1 over 10. 1 over 10. Our D says 0.0001. Now let's express this in standard form. This will be 1 times 10 raised to power 1, 2, 3, 4 raised to power minus 4. That is our what? Standard form. Now to express this in standard form, let's identify the non-zero number 6.82 times 10 raised to power what? 1, 2, 3, 4 raised to power minus 4. So these are the way to express your what? Your decimal numbers in standard form. Now before you use this trick, kindly make sure that you have already understood the steps that we follow in the first question that we solve. The step 1, 2, 3 that we follow the first question and so then if you have already mastered this, you can now start using your words to trick, which is the easiest way to express your words to your number in standard form. So we want to convert numbers in standard form back towards an ordinary number, either whole number or decimal number. Now to go about this, looking at this number here, you have 6.3 times 10 raised to power 4. Now 10 raised to power 4 simply means what? Tens of thousands. Can you see? This is what it means. Now we are having 6.3. We need to convert this back to what? To a whole number, either whole number or decimal number. Now 63 divided by what? By 10. Now 63 divided by 10 is going to give us this. We say times what? So tens of thousands. Is that okay? Now in this case now, you can reduce this number. You are left with 63 times 1000. So 63 times 1000 will give you what? 63,000. If you don't want to take this method, which seems to be what a bit longer, you can just use your trick straight away. You can use your trick. And what do I mean by your trick? When you are given a number, let's say 6.3 times 10 raised to power what? Times 10 raised to power 4. This simply means point. Now you're going to move your pointer many times, 4 times. Let's go. 1, 2, 3, 4. So you just occupy the word, the empty space with what is 0. You are having your word, your 63,000. You can see you're still getting your word, your answer. If you don't want to go with this long method, you can easily use the word the trick. You're still going to get your answer. So now let's use either of these two methods for the remaining question. So we have 8.2 times 10 raised to power 4. 8.2 times 10 raised to power 4, we can express this as 8.2 now times tens of thousand times tens of thousand. And what does that mean? We need to move our decimal point. Let's go 1, 2, 3, 4. 1, 2, 3. So this would be what? 82,000. That's what it means. That is what 82,000. The next one, we are having 1.9 times 10 raised to power minus 3. 1.9 times 10 raised to power minus 3. Now, in this case, this is what the decimal number. So, having this number, we can say 1.9 times 1 over what? 1000. Now, 1.9 over 1000. We can also express this to be 19 divided by 10 times 1 over 1000. Either way. But I choose to start with this word, this decimal point. Since we're dealing with what decimal point, we have 1.9 over 1000. And this can be expressed as 1.9 over 10 raised to power 3. Now, 1.9 times 10 raised to power 3 can be expressed as this. Let's move our point to the right. 1, 2, 3. Put your points. You fill up the empty space, so you are having 0.0019. That is the expression in what the ordinary number. This is a decimal number. To be precise, this is the decimal number. So the next one is this. That is D. We are having D. D is 2.7 times 10 raised to power minus 4. 2.7 times 1 over 10 raised to power 4. 2.7. Let's move the decimal point. How many times? 4 times. 1, 2, 3, 4. Put your point. Balance it to 0. That's your whole number is definitely 0. So you have 0, 0. So this is how to express this. 27. That is the ordinary number. So let's have the next one. If your E is 8 times 10 raised to power minus 5. So this is 8 times 1 over 10 raised to power 5. So to go about this, you have your 8. We're going to move our decimal point from the back of the word of the non-zero number, which is to remove 1, 2, 3, 4, and 5. Put your point here, add the 0. Fill up the empty space with your word of 0. So the final answer will be 0.00008. That is your final answer. And this is how to express or convert a number in standard form to an ordinary number, either whole number or decimal number. So the next aspect we're going to discuss now is the ordering of standard form number, either from the smallest to the biggest, the order then from the biggest to the smallest, vice versa, as the case may be. So the examiner asks us to put the following numbers in order of size. Start with the what? With the smallest. Now, how are we going to go about this? Now, let's go. The first question, which is 3.8 times 10 raised to power 3, comma 6 times 10 raised to power minus 2, comma 1.92 times 10 raised to power 4, comma 4 times 10 raised to power 3. Now we're going to order these numbers from the smallest to the biggest. How are we going to go about it? We have 3.8 times 1000. That's what it means. Next one is 6 times 1 over 100. That's what this also means. We have 1.2. We have 1.92 times 10 raised to power 10,000. That is what this also means. And 4 times 10 raised to power 1000. That's what that other number also means. Now, to express this first one, we can use either way. We can use our trick, and also we can also express this as 38 divided by 10 times 1000. This 1 over 100. We can have this to be 192 divided by 100 times 10,000, comma 4 times 1000. So here we can reduce the number and we are going to be left with 38 times 100, comma this will still remain 6 over 100, comma this 20 will cancel 0, so we have 192 times 100, comma 4 times 1000. So this will be 3800. That is 3800. That's what it means. Now this next one, 6 divided by 100. 6 divided by 100, that is the base value of this is what? 100. So we are going to be having 0.0. This is 10. Then we have 100. The next one, this will be 19200. So this is 19,200, comma 4,000. That's what it means. Now let's order this number from smallest to the biggest. This will be 0.06, comma 3800. That's 3,800, comma 4,000, comma 19,200. Let's express them back in the standard form so that we can identify the answer, provided the examiner gives us the word options. If you are not given option, just what leave your answer like this, or you express your answer in the way the examiner has given it. So we have 6 times 10 raised to power minus 2, comma 3.8 times 10 raised to power 3, comma 4 times 10 raised to power 3, comma 1.92 times 10 raised to power 4. So this is the answer, smallest to largest. Alright, so with this explanation, I believe when you see similar questions, you'll be able to order numbers in standard form, either from biggest to smallest or from smallest to biggest as well. So let's move to the next aspect. Now let's order the next number from smallest to largest. So let's start with this. We have 2.7 times 10 raised to power 5. This means 100,000. 10 raised to power 5 is 100,000, comma 28 times 10 raised to power 2, that is 100, comma 0.275 times 10,000. That is what that also means, times 10,000, comma 0.29 times 1 over 100. So here we can say 27 divided by 1 times the 100,000 that we have here. So then we cancel out 10 here. So we are left with 27,000. That's 270,000. 270,000. Okay, let's go for the next one. This is 28 times 100. That will give us 20. That will give us 2800. That's 2,800. Next one is 2,800. Let's order the next one. For this one, we can express this number as a whole number. 1, 2, 3. So that will be 275 divided by 1,000 times 10,000. So you can reduce this number and cancel all this. So you are left with 2,750. That's 2,750. That's what we are left with. So the next one we can say 29 times 0.01. 29 times 0.01, and this is going to give us 0.029. Now let's order this number now from the smallest to the biggest. From the smallest to the biggest, the smallest number here is 0.029, comma 2750, comma 2800, comma 270, comma 000. Let's take the standard form number. We have 29 times 10 raised to power minus 2, comma 0.275 times 10 raised to power 4, comma 28 times 10 raised to power 2, comma 2.7 times 10 raised to power 5. So we just express the number from the smallest to the largest or the biggest. our next class, we're going to talk about addition, subtraction, multiplication, and division of numbers in standard form. That will be our next class. So watch out for the next topic on addition, subtraction, division, multiplication of numbers in standard form. Thank you very much. If you love our video, kindly click the like button and press the notification button. See you in the next